Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. First of all, in this cheerful session of the 4th Borobudur International Symposium, allow me to thank for opportunity that has given to me to present the research with the title Effect of Pumice-Based Nanosilica and Sodium Silicate Addition on Impact Strength of GFRP Composite. And the next, let me introduce myself as a speaker. I'm Willy Akhsani Taqwim from Mechanical Engineering Department, Engineering Faculty 11 Maret University, Surakarta, Indonesia. Okay, now we are going to move to the main presentation. The first session is an introduction. The background of this research is the abundant availability of pumice in Indonesia. This is due to the geographical location of Indonesia, which is in the Ring of Fire area. This geographical location causes Indonesia to become a country with high volcanic activity. The volcanic activity from the volcanoes in Indonesia causes an abundance of mineral material deposit. One of them is a sedimentary rock in the form of pumice. The abundant availability of pumice can be used as an alternative raw material for making a nanosilica particle to become a filler in GFRP composite. GFRP is a part of composite material that has a constituent structure in the form of glass fiber. The GFRP composite have been widely used in industry and transportation sector. One of the constituent structure of GFRP is a glass fiber. Glass fiber is one of the most widely used type of reinforcement due to the consideration of its thermal properties, electrical insulation, sound absorption, corrosion resistant, and relatively low cost when compared to carbon fiber. In composite material structure, two types of glass fiber configuration are generally used. The first is chopped strand mat and the second is woven roughing mat. In several studies have proven that a composite with unsaturated polyester resin composition reinforced with woven roughing mat glass fiber shows a good strength, whereas the composite with a chopped strand mat reinforcement has a good flexural strength, so that the combination of chopped strand mat and woven roughing mat glass fiber on GFRP composite material is considered to be able to create the best mechanical characteristic. The GFRP composite material have flexibility in terms of modification to achieve a characteristic that suits the need. Modification of GFRP composite can be performed by adding a filler to the composite composition. The filler used in composite can be a nanofiller and viscose liquid filler. The addition of the filler to the GFRP specimen was considered effective in improving the physical and mechanical properties. In this study, we use two types of filler. The first is pumice-based nanosilica or nanofiller pumice particle, and the second is a viscose liquid filler in the form of sodium silicate. From the description above, we conducted a study with the aim of knowing the effect of adding nanofiller particle of pumice or NFPP and sodium silicate on the impact properties of GFRP composite. And then we are going to the next slide about material and method. In this study, the fabrication of GFRP composite uses a matrix of unsaturated polyester resin mixed with a nanofiller pumice particle and sodium silicate according to the concentration listed in the following table. As we can see, the following table displays the content of GFRP composite. The first is a C composite, which is a composite without the use of filler. The second is the composite C41, which is a composite containing a 10% nanofiller pumice particle without a sodium silicate addition. Next is the C42 composite, which is a composite containing 7% nanofiller pumice particle and 3% sodium silicate. Then C43 composite is a composite containing 5% nanofiller pumice particle and 5% sodium silicate. The C44 composite is a composite containing 3% nanofiller pumice particle and 7% sodium silicate. And the last one is the C45 composite, which is a composite containing a 10% sodium silicate without the addition of a nanofiller pumice particle. In processing pumice into a nanosilica particle, in general it can be done in three main stages. The first step is a preparation, then extraction, and the last is titration. In preparation process, pumice was washed with a distilled water to remove a dirt, then dried at 100 degrees Celsius for 12 hours. A pumice is crushed by a crusher machine to produce a pumice particle. Then, the pumice particle were sieved to a size of 200 mesh or 74 micrometer. After that, they were washed and thermally treated at 680 degrees Celsius for an hour. On the extraction process, 100 grams of pumice particle were dissolved in 1000 milliliter of 2.5 mol hydrochloric acid and stirred with a magnetic stirrer at 300 rpm at 95 degrees Celsius for 2 hours to separate the silica-rich pumice particle. In the titration process, the particles were washed with distilled water until they reached a pH of 7. The sodium silicate solution was prepared by dissolving 10% of silica-rich pumice particle in a 2 mol natrium hydroxide at 95 degrees Celsius for 2 hours. The solution is filtered to separate residue and impurities. Sodium silicate was precipitated using a 10 ml ethanol dispersion and 5 mol nitric acid. The solution was filtered to get a silica gel. Then silica gel is dried in oven at 80 degrees Celsius for 4 hours to get nanosilica particle. In the production process of GFRP, a 3000 rpm stirring process was performed for 5 minutes to do the mixing process between a matrix and filler. Then the catalyst was added just before pouring into the mold. The glass fiber types of top strand mat and woven roughing mat are used in the arrangement as shown in the picture beside the table. The fabrication process was executed by a hand layup method followed by press mold process, which was performed at room temperature. After the process is complete, post curing is executed at 100 degrees Celsius for 60 minutes. After the completion of fabrication process, GFRP composite were prepared for dimension of length, width, and thickness respectively 64, 13, and 3 mm. 7 pieces per variant for impact testing, which would be executed out using the impact isotope method. After that, the same observation process was performed on the sample that had gone through impact testing to analyze the structure of the GFRP composite. Then the next slide is a result and discussion about an impact test. The chart shown below is the result of impact isotope testing on GFRP composite. As we can see, from the scope of filled sample, C41 composite, which only filled with Pumice-based nanosilica filler without using a sodium silicate filler, has the highest absorption energy and impact strength among the other. The results are caused by a combination of the use of woven roughing mat, nanoparticle, and chop strand mat in the GFRP composition that causes a strong bond between a matrix and reinforcing material. The use of nano-size filler is considered to be able to affect the morphology of the polymer and increasing the toughness of the material due to the crack deviation process. From the following chart, it can be seen that the C44 composite with containing 3% of nanosilica and 7% of sodium silicate has a better strength than C43 composite which containing 5% nanosilica and 5% sodium silicate. This phenomenon is due to the role of sodium silicate in the distribution of homogeneous particles, which can help to minimize porosity. The C43 composite has the lowest impact strength compared to the other composite. The addition of nanosilica particle and sodium silicate with the same composition ratio can reduce the strength of the composite by reducing the bond strength due to the powder agglomeration. Okay, let's move on the result of a SEM observation. As we can see, the following images are the result of GFRP composite scanning electron microscope observation that have been gone through impact testing. From the result of SEM observation that have been done, sample without filler or C composite shows a fairly good interfacial bond between the fiber and the unsaturated polyester resin. The C41 composite shows a good interfacial bond between a glass fiber, matrix, and filler. This is in line with the result of the impact test that C41 has the best impact strength among the other filler specimens. The C43 composite has the lowest impact result among the other specimens. As we can see at this picture, it has been observed that in the C43 composite, there are areas of filler agglomeration that cause a decrease in impact strength on the specimen. In the composite C42 and C45, it can be seen that there are a fiber pull-out in most of the fracture area. This phenomenon indicates that the binding ability between matrix and fiber is still not good. Then, the distribution of the composites looks poor, causing many cavities which lead to a decrease in ability to receive impact load. And then the last part of this presentation is a conclusion about this research. From the research that has been done, it can be concluded that the impact test result show that the specimen with nanosilica filler without a sodium silicate have a better impact strength than the other filled specimen. This is because the combination of the use of woven glass fiber, nanoparticle, and chopped glass fiber in the GFRP composition causes a strong bond between the matrix material and the reinforcing material. Low impact strength is in the composite, which has a composition with the same concentration of nanosilica particle and sodium silicate. This phenomenon occurs due to the agglomeration of the filler used and poor interfacial bonding. These data are supported by a scanning electron microscope observation, which show that the composite filled with nanofiller pumice particle have a good interfacial bonding. The composite with the same concentration of nanosilica and sodium silicate shows accumulated filler agglomeration. From the results that have been obtained, the composite containing flame retardant filler in the form of nanofiller pumice particle was considered to be able to maintain mechanical properties in the form of impact strength compared to the other filled GFRP composite material. Well, ladies and gentlemen, that's what we can share with you about the result of our study about the effect of Pumice-Based nanosilica and sodium silicate addition on impact strength of GFRP composite. I hope this research can be useful for us. Thank you for paying attention to this presentation. Wassalamualaikum warahmatullahi wabarakatuh.